The ArcGIS Maps SDK for JavaScript is the best solution for creating custom applications that can be used across browsers, across devices, and across your organization. Whether you're using NPM or CDN, whether you're using React, Angular, or Vite, we have the solution and documentation for you. The SDK allows you to build 2D and 3D web applications that can visualize anything from small datasets to large datasets with fast performance. You can build interactive analytical web apps taking advantage of our client-side querying, client-side filtering, and client-side geometric operations. On the right side, you can see our new and improved. As an amazing coworker of mine says, there's so much has been released in the last year. Batch editing for maximum productivity, track rendering to visualize real-time data, 3D flow renderer, 3D base maps, calendar heat charts. With just a few lines of code, using the SDK's components, you can build compelling and amazing experiences and make your data come alive with dynamic visualizations and client-side analysis. To show you how to build apps with components, here is Julie.
Thanks, Bjorn. OK, here we are in Map Viewer. We're looking at the web map that Jeremy made earlier with the helicopter flights and the noise complaints in New York City. Now, there's a lot baked into this web map. I can click on a census track and see a really informative pop-up. I've got bookmarks here for different areas of interest, like Central Park. And I have a collection of charts, like this calendar heat chart, showing me the density of when flights were taken. Now, I'm going to use this web map to create an application that lets me further explore this data and really understand the relationship between the helicopter tracks and the noise complaints. To get started with the JavaScript SDK, you have many options. Of course, you have the sample code, we have tutorials, and now we have a few new ways of getting started. Now, if you're using the CDN, you only need a single script tag to start your application. That brings in calcite, the SDK, and the style sheets. Now, if you prefer to take a template approach, we now have an ArcGIS Create CLI. Now, let's have a look at that in action. Here we are in VS Code. I'm going to run the CLI. And the first thing it's going to want is a name for my project. And then, as you can see here, I have all the different popular frameworks I can choose to build out my app. I have React, I have Angular, or I can just simply create one with the CDN. So as it's downloading my files, I can have a look at what we have here. And what it's doing is it has a calcite shell, and that's managing the layout. Calcite is Esri's design system, and I can use it to build out my UI. I also have calcite navigation for the header, and then here I have an ArcGIS map. Now, right now, it's just referencing a default web map. I'll update that later. It's got the zoom component, search component. It has a legend inside the expand, and then it has a chart also referencing a default chart. Now, I've gone ahead and updated this for my application. And I referenced Jeremy's web map here with the item ID. I've chosen to use the zoom component. I've brought in the bookmarks component. I have the legend. And then I've also updated the chart to use Jeremy's chart. Now, let's have a look at what we get with just that code. So here I have the application. You see the legend. I can click on a census track, see that information. I've got bookmarks, so I can zoom into Central Park again. And then I've got my calendar heat chart. Now, I could just be done here or continue to build out my experience. And I really want to build in some more tools to explore this data. So what I've done is create a calcite panel to really start organizing my UI. So if I click on a census track, rather than displaying the pop-up over the UI, I've decided to embed it inside the panel. I've also decided to put the heat chart in here as well. Now, this is a really great visual, but I also want to explore it from a statistical perspective. And the good news about the SDK is, in addition to the web components, you also have access to the full underlying core JavaScript library. So here we have a sample that inspired me. And as you move the cursor around, it's doing a buffer and then calculating statistics on the fly as I move it around. So I've used that logic in my application, and I'll go ahead and turn that on, and maybe we'll go to Brooklyn. And as we look around this helicopter corridor, we're looking at total population, average income, and the noise complaints. I can also go to Central Park, and in a very small area, we see that there's 7,500 noise complaints just right there. Now, the next thing I want to do is explore it from a time-based perspective. So when were these helicopters flying, and start kind of looking at the relationship with the noise complaints. So in the chart, at my first attempt, I'm going to look at Valentine's Day, and all these lucky New Yorkers are sure flying a lot on Valentine's Day. And this can be great when you're highlighting the map, combination with the chart. But in my case, this isn't really helping me a lot because I have so much data, 700,000 segments, they're overlapping. So I really can't understand a whole lot from this view. So instead, I am going to filter the data based on Valentine's Day. And now we're just seeing the tracks that were flown on Valentine's Day. And I also have the list of helicopters that flew that day. I'll pick one, and I can see this pilot's specific flight. This chart is also coming from Jeremy's web map. And I'll select a specific flight, and we see it highlighted on the map. And I've also done a test to see which noise complaints happen within half a mile of that helicopter track and around the same time. So maybe this particular flight contributed a little bit to those noise complaints. Now, I hope what you could see in this demo is that you can be incredibly productive with the JavaScript SDK components combined with your web map. And you still have full access to the underlying JavaScript core library, so you can really build powerful applications that are unique to your organization. So with that, I'll hand it back to Bjorn.
Thank you, Julie. Let's talk about web editing. Our SDK streamlines data creation and data editing. You can use templates to create one feature or many features at a time. You can use form-based editing for maximum accuracy and productivity. You can use fully editable feature tables that handles complex things like utility networks or contingent values. With our recent February release, we're also excited to announce full support for curve drawing and curve editing capabilities on the web. To talk, that's awesome. To talk more about awesome curve editing and web editing in general, here is Jose.
Thanks, Bjorn. The SDK enhances drawing API this release to support true curves in 2D. This means built-in support for drawing, editing, and snapping to true curve geometries through the sketch and editor components. Let's walk through a workflow that utilizes the new drawing enhancements in Sketch. I'm going to create a holiday parade route along this park using the new curve tools, and then I'll share this route into my planning organization. I'm going to use Sketch to create a line using a custom line symbol that I've set, and notice how the toolbar updates to show the new curve segment tools. I'm going to start by creating a straight line segment, then switch to the new circular arc tool, as Sketch now allows us to switch between drawing tools while actively creating lines or polygons. The supported curves this release are circular arcs and Bezier. With Bezier arcs, we can use the Bezier handles to modify the curve as we create the line segment. And the Bezier handles are available when creating or updating geometries with Bezier curves. This new segment-based approach allows us to quickly switch between drawing tools to create a smooth curve path along this park. Now I can use the print component to print this route and share to my planning organization. True curve support also extends to editing feature services through the editor component. Just like Sketch, editor drawing toolbar now displays the new curve segment tools. And here we have a crop mapping application centered in the county of San Joaquin in California. And I've drawn an area on the map that represents the crops that will be harvested in this location. I used the new curve tools to draw the curved segments along the San Joaquin River. But I do notice that at the bottom right corner, I still see a straight line segment that I'm going to convert into a circular arc to better represent the curved path along the river. Now I can use the split tool to divide this area into two sections for harvesting different crop types. Thanks to the split operator support for true curves, we can now split curve geometries. And splitting is made easier with snapping support for true curves, as I can now snap to a curve segment on the polygon, snap to the other end to complete the cut. And one section will be used to harvest almonds, and the other will be used to harvest oats. I've also set up an arcade expression that automatically calculates the area of the polygons and converts the units into acres. So just like drawing and editing, Arcade now respects true curves. Once I complete the edit, we'll see the area labels update, and we're done. Two-dimensional true curve drawing and editing support built into the sketch and editor components opens up the possibility to perform more sophisticated editing workflows on the web. Thanks. Now back to you, Bjorn.
Thank you, Jose. That's some cool curves. This really shows how we're working to bring powerful capabilities from the desktop to the web, allowing you to create very tailored workflows. Now let's talk about 3D. The 3D capabilities on the web to bring together advanced client-side analytics, rich visualization, and modern data management. You have access to exploratory analysis tools like the shadow analysis, viewshed analysis, and the new volume measurement. When it comes to visualization, our SDK gives you the full flexibility with how your users experience your data in 3D. For example, you can use realistic effects, or you can have your applications zoom into a specific area using user focus. You can work with a wide range of data formats, including point cloud, voxel, mesh, and the new Gaussian splat layer, which allows you to create very photorealistic scenes. To show most of the recent improvements in 3D, here is Matteo.
Thanks, Bjorn. In this 3D scene, we are looking at an integrated mesh focused on stockpiles. In these scenarios, you could start with a 2D site plan that allocates areas for each different material, like these polygons for the expected asphalt stockpiles. Before the latest releases, I could already calculate these areas, but what I really wanted to do here is to get the volumes. So, since recently in the JavaScript SDK, I can programmatically use the same polygons as input to calculate the stockpile volume on top of the integrated mesh. These volumes are represented in the scene using the green color, and their values are in the cut labels. I can also fine-tune the boundaries of a generated volume analysis, making sure the results are correctly. And this is not just a visual result. In fact, I can extract numerical results and either use them in the UI or feed them into a custom workflow. All right, now let's switch from analysis to visualization and see how we can use some of the new capabilities to make things stand out in a 3D context. When reviewing a proposed building, you often need to consider the surrounding neighborhood. Using the focus area, I can dim everything beyond a 5 minutes walk from a specific building and keep the attention on what really matters. But in a dense 3D scene, icons can easily end up behind buildings. For this reason, we added a new property for icons and labels called occluded visibility. The new default mode is adaptive, that automatically improves readability and reduces clutter by making occluded icons transparent while navigating the scene. Otherwise, you can set it to hidden to visualize only non-occluded icons, or set it to visible, and all the POIs will stay visible even if they are behind or within other 3D objects, like these emergency exits here. And to really emphasize key elements, we added support for emissive materials and glow. Let me explain what I mean. This building model already has parts that are meant to emit light, such as the LED strips or the shining through windows. So when the scene gets darker, those emitting objects, by simply enabling the glow on the scene component, emit light. And this is not limited to models. In fact, we can add emissive property also to 3D symbology, like points, paths, or emissive or extruded polygons, to create symbols that are emissive and glowing, like I did for these custom floor selectors. Let's keep going and look at another new way to visualize data in 3D. Magnitude and direction data like wind, ocean currents, and flood simulations have been visualized in 2D using the flow renderer for quite some time. Now, we can use the flow renderer also in 3D. And while navigating the globe, you can clearly see how it behaves across different regions, countries, and continents. But this also enables new ways to vertically explore the data. For example, I can position the flow at an absolute height to analyze it in isolation, or I can set the relative to ground mode to visualize the wind at its real sampling height following the terrain. And to conclude, I'm really excited to share that we now support the Gaussian splat layer on the web, which is the right choice for you if you need an ultra-realistic 3D representation. The smallest details of this substation, like these insulators, can be inspected with an incredible fidelity, capturing fine wires and structures that traditional layers usually struggle to represent. And of course, this new 3D layer is integrated in our ecosystem. So for example, you can do measurements on top of it to get an accurate picture of the reality and the site without having to physically be there. So we have seen how these new capabilities can extend what you can build in your 3D web applications using our SDK. For example, how to programmatically use the analysis framework, or how to make things stand out in a 3D context. And finally, how this new 3D layer can make your web scenes feel more realistic and communicate a GIS story to any audience. Back to you, Bjorn.
Thank you, Matteo. It's very impressive what you can do with the 3D today. And that Gaussian splat layer really looks amazing. Next, I'd like to talk about Parquet. Parquet is an open, column-based data file format. It's used heavily in the data science community. It's cloud-friendly. It can store any data size. It can store data sets of any size. Or Parquet does not have traditional indexes. It can still support server-side big data processing. In 2025, we introduced the Parquet layer to support Parquet data. We read the Parquet files directly without any middleware. We've added full capabilities similar to our other client-side layers, so visualization and interactive query workflows. But what about very large Parquet data files, or having complex geometries? To show some of the exciting work with working with large Parquet files, here is Matt.
Thanks, Bjorn. Cloud-native formats like Parquet enable data scientists to explore massive data sets stored in the cloud. Using a Jupyter Notebook, I can run queries on a remote Spark cluster. And then, with GeoAnalytics Engine, I can extend Spark for advanced geospatial analysis. However, visualizing this data on a map often involves complicated workflows to generate vector tiles or process the data for display. Today, we're showing our new format for spatially optimized Parquet. We start with a directory containing 11 million census blocks. Then, using GeoAnalytics Engine, I can call the withGeoDisplay function to optimize these files. By setting them parts equal to 1, we're telling GeoAnalytics Engine to output a single file. And if we look inside this file, we can see that all of our original data is still here. It just includes an additional column. This column consists of 3 parts. First, we create a cluster key derived from the extent of our features. Second, we sort based on this key. And third, we include a series of multi-scale columns that include optimized geometries for the features at different scales and resolutions. And because this is just Parquet, I can still query the data as I would normally, and I can create charts and graphs. However, what this approach allows us to do is visualize this data on a map. Here, using the Maps SDK for JavaScript, I'm creating a new Parquet layer pointing directly to our file, which is hosted on an Azure bucket. As I pan around the map, we can see the Maps SDK making a series of range requests. Our implementation, built on top of Rust and WebAssembly, dynamically loads just the data needed for a given extent. And as I zoom into New York City, we can see the Maps SDK automatically update with higher resolution geometries for the features in our extent. Space-filling curves are at the core of what makes this work. These curves map data from a higher dimension to a lower one, while approximately preserving spatial locality. Here, we take the extent of a feature and we map that to a single XZ code. By sorting based on this code, we effectively create what you can think of as a kind of multi-resolution grid that can be used to accelerate spatial operations. And the best part about this approach is that it works with the page statistics already built into Parquet. Now, Parquet also stores data for the same column close together. That means that as I update our render, we can see the Maps SDK again dynamically update with just the data needed for my new demographic columns. Here, I'm using a dot density render to draw one dot for every 7 individuals. And we can see this again when I do stuff like add a feature effect. The Maps SDK is built on the same feature rendering and processing and querying pipeline as our other layers. That means it has access to many of the same types of visualization capabilities. However, the Parquet layer can scale to even larger layers. Here, we're looking at the Overture Maps building footprint dataset. In the bottom left, if I query the layer view, I can see that there's nearly 2.3 million features in our current extent. And if I query the layer as a whole, we can see that there's nearly 2.6 billion features in the dataset altogether. These 2.6 billion features are spread out into 16 individual Parquet files, each file about 25 gigabytes large. Because the Maps SDK is able to dynamically stream in just the data from the files that we need, we're able to do stuff like visualize cities spread across the globe. We're just getting started with Parquet, and we have a number of improvements coming for later this year. And with that, I'll hand it back to Bjorn.
Thank you, Matt. It's very impressive what you can do with this spatially optimized Parquet. Now, while Parquet is great for these huge data sets that don't change frequently, Parquet still requires you to manage and maintain these files separately from your data store. And workflows that requires full editing or taking your data offline and sync require a queryable and updatable data store. In most cases, feature layer powered by feature services is still going to be your best solution. Feature layers are editable. Feature layers are easy and simple to manage. They're scalable. And for most data sets, they're still the most performant option. As for Parquet, look for future WebJS integration this summer. To recap this session, Julie showed some wonderful web components and how to get started. Jose explored the new cool curves and the latest in web editing. Matteo showed us the 3D advancements and really exciting to see the Gaussian splat layer. And Matt then showed us some impressive performances with the Parquet layer. So to summarize, the ArcGIS Maps SDK for JavaScript is the best solution for creating custom web application. That's it for me. Back to David.
All right.